In 11th organic conversion, we have methane and we need to convert it into ethanol. This is very simple. It has about 3 or 4 steps. First of all, we should chlorination this methane with chlorine and H-mu-rase, and we will have CH3Cl. That means chloromethane. After making chloromethane, we have to use alcoholic potassium cyanide. For the alcohol, I can use ethanol. I use ethanol and potassium cyanide. Then CH3 minus, CH3 and Cn minus, this becomes basically this Cn minus is a nucleophile, and then this Cn minus nucleophile substitute for chlorine. Then this reaction becomes an nucleophilic substitution reaction. After making CH3Cn, we have to use H2O. Then this is the CH3COOH that becomes, this can be known as ethanoic acid, and ethanoic acid can be converted into ethanol in one step. For that we have to use lithium aluminium hydride in ether medium, and then we have to use H2O. Exactly our last step, that means CH3COOH becomes CH3CH2OH. That reaction is a reduction reaction of ethanoic acid. In our 11th organic conversion, we have to convert this organic compound into this one. You can see this compound comprises with 2 bromine atoms, and we need to reduce it into 1 chlorine atom. Initially, we have to use dilute potassium hydroxide or sodium hydroxide. Then this becomes OH minus, and OH minus is the nucleophile in this first step, and that becomes a nucleophilic substitution reaction. The product should be just like this. Product is a diol product like this. That means this organic compound comprises with 2 OH group. On 1 carbon atom, it has 2 OH groups. We will reduce 1 H2O molecule because this organic compound is unstable. Then we can have this one. This is a ketone. This ketone can be known as propanone. After making propanone, we should follow about 2 steps to make this one. Thereafter we have to use lithium aluminium hydride in dry ether medium. That reaction makes this secondary alcohol. Then now you can see we have to follow only 1 step to make our final one. Then we have to use PCl3 or PCl5. Our last step should be a nucleophilic substitution reaction, and the nucleophile is Cl minus. Let's consider about our 13th organic conversion. In this one, you can see this corner carbon has 2 bromine atoms, and these 2 bromine atoms should be attached with this middle carbon atom. So initially I need to use alcoholic potassium hydroxide or sodium hydroxide. For the alcohol I can use ethanol. Then I use ethanol with potassium hydroxide. Then we can have this alkyne. This alkyne can be named as propyne. when we are going to make this propyne, we have to remove two HBr molecules from the initial organic compound. After making propyne, we have to follow only one step. In that step, we have to use hydrogen bromide in CCl4 medium. CCl4 means carbon tetrachloride. This second step becomes an electrophilic addition reaction, and the electrophile is hydrogen plus. Also, two HBr molecules attach with this propyne. Hydrogen attacks with the corner carbon and the Br attack with middle carbon atom. In our 14th organic conversion, we have to convert ethanol into ethyne. Initially, we need to make alkene. This is the alkene we need to make. To make this alkene, we have to use concentrated sulfuric acid and 170 Celsius degree. This is an elimination reaction. Eliminated compound is H2O. After making ethene, we have to use HBr, hydrogen bromide in CCl4 medium. Then we will have CH2Br and CH2Br. Then now we have to follow only one step. In our final and last step, we have to use alcoholic potassium hydroxide or sodium hydroxide. For the alcohol, I am gonna use ethanol. Ethanol structure is C2H5OH, and potassium hydroxide I am gonna use. Then we can remove two HBr molecules, and I will show you how this third reaction is gonna happening. We need to remove Br with adjacent carbons hydrogen like this, and thereafter this Br takes a carbon hydrogen atom from this adjacent carbon atom. Then two HBr molecules can be eliminated. In our 15th organic conversion, we are provided calcium carbide. This one is calcium carbide, and then we need to make this organic compound. You can see this organic compound comprises with two carbonyl groups. These are carbonyl groups. So initially we have to use H2O. This calcium carbide reacts with H2O, that makes calcium hydroxide. This is calcium hydroxide, and this makes ethine. This one is ethine. Then I will show you the structure of ethine. The hybridization of one carbon atom is sp. After making ethine, we need to use KMNO4, potassium permanganate, in OH minus medium. That means in alkaline medium we have to use KMNO4 with ethine. After this reaction is happened, we will have this organic compound. You can see one carbon atom comprises with two OH group, just like this. Then now you know, when one carbon atom has two OH group, that organic compound is going to be unstable. Then this one can be known as unstable organic compound. So we can remove two H2O molecules like this. After removing two H2O molecules, you can see we will have this organic compound. This is an elimination reaction and the eliminated compound is H2O.